Okay, so welcome. This is the week 4 webinar for our statistics class. And today will probably not be that tough and not that long. That's always a, pretty good thing. Let me go to share my screen and talk about the plan for today. Okay, so the plan today is, as always, I'll start out with any questions that you might have, and I'll be happy to answer them. And that could be about, the assignments due or about the project, because at this point, you should all be making good progress in the project. And strongly recommend, if you haven't in a while, especially, make sure you contact your project partners. And if you don't have a partner, make sure you get one and go on the Project One discussion board and see if there's anyone that looks like they might have bailed from the class, or if it looks like maybe there's only a pair and they can grab a third person. But again, that's a good way to do it. You can also put in the chat box if you want to find another partner. And at least for the few of you who are here, that's definitely something you can do. So I'll start out with any questions you might have. And then after that, we're going to get into the standard normal distribution. So if you remember last week, we talked about the uniform distribution. And it turns out the uniform distribution is not that useful, but what it does is allows you to do calculations and understand them because it's just rectangles. And that's something we can actually do. So the uniform distribution is, it was important, but not that useful. On the other hand, on a scale of 1 to 10, with 1 being completely useless and 10 being, the most useful of anything, I'd say uniform is probably around a 4, and the normal is a 10. It is the distribution for this entire class. Okay, we'll have some other distributions, but the normal is the big one. And everything we do for the rest of the class either uses the normal distribution, or it turns out it uses the distribution built on the normal distribution. So we need to understand what that is. This week, you're not going to really understand why the normal distribution is important. Again, the whole rest of the class pretty much uses it. Next week is when we find out why. So this week, just trust me. Sound good? Okay. We'll talk about, from the normal distribution, calculating probabilities and percentiles. We'll look at the general normal distribution, and that basically is when you have a mean and standard deviation, whatever it might be, instead of something very specific with the normal, with standard normal, which happens to be 0 and 1. And we'll calculate probabilities and percentiles for that. And then finally, I'll give you an application. Always fun to do applications. And that is the plan for today. So as I mentioned, we're only doing chapter 6. For the rest of the entire class, we only do 1 chapter a week. Whether you like it or not, I like to start out a little bit faster and then end a little bit slower. And one of the main reasons for that is I know sometimes your other classes, they get hard at the end, so I try to get a little easier at the end. So, if you felt like the class is just tearing you down, it slows down a little bit now. But you still have the project to do, and that always takes a lot of work. And I want to remind you, make sure that you don't wait till Sunday to start writing your project. You really want to have your full draft written by Wednesday so that you can send it to me, then I can look it over, and then I can give you suggestions for improvement. So that's important. And then just for your plan, and several of you have done this already, make sure you post on the Project One discussion board what your plan is so that I can look at it and say, yep, that's going to work, or that almost works. You just got to kind of make this one little addition or refinement, or, well, that doesn't work, so think of something different. So what you want to do is look at the project discussion board and look what I've commented on other people's proposals. And that way you'll get to see what works and what doesn't work and what you need and make sure of. So that helps also before you even post yours, if you haven't posted yet. Are there any questions about anything? Okay, that could be about the project, could be about the chapters, whatever it is. And also look in the chat box. Somebody is looking for a partner. So if there's only 2 of you, make sure that you welcome them. You know, it's always easier to have 3 people because it's less work to do each person because it's one project for all 3 of you. Any questions? Questions? I always like to answer questions. And again, that's a big part of this is to make sure that questions are all answered.
Can I share my survey question with you at the end?
Yeah, you could also put it on the project discussion board.
Okay, I just
And
find
you
it a
can
little
even do
easier.
it while we're talking, and then I can share the project discussion board with everyone, and everyone can see what it looks like. Does that make sense?
Yes.
Yeah, that's even better. And then that will work that way. And at the end, I'll do it unrecorded so that there's privacy stuff, if that
Okay.
makes sense. So
Yeah,
we'll
that
do
would be very helpful.
yeah.
Thank
Yeah,
you.
always happy to help out. I want to mention one more thing that I forgot to mention, and this is a rare thing, but it's going to happen. I'm actually going to be in an airplane on Thursday during office hours, so I'm not going to be able to be in office hours. I have a conference for calculus to go to, and Thursday and also Friday, I will not be in office hours. So if you come to my office, then it'll be a locked door and you won't be able to come in. I will be checking on and off email, you know, when I'm not on an airplane and, you know, or when I'm in the airport and sitting around waiting for the next plane, that kind of thing. So I'll still be, you know, in contact with you guys, but I won't be in office hours Thursday and Friday. So please note that. So don't get upset if, you know, you try and I'm not on Zoom then because I won't be. But I will be checking the discussion boards and I'll be answering emails too. Okay, so let's talk about the standard normal distribution. As we saw before, we had the uniform distribution, and that was just one rectangle, if you remember. So it was a rectangle and that was a uniform distribution. And as I just mentioned, it's not all that useful, comes up once in a while. The biggie is a normal distribution. And again, today's not the day you're going to be convinced. That comes up next week. So right now, just trust me that this is the most important distribution of all distributions of all statistics. So this is a big one. So here's the shape of the normal distribution, standard normal distribution. And do you know what this is also called? Anyone know what this shape is also called? It's the one most people think about or have heard of. Especially think about grades, for example. Yeah, it's a bell curve. Okay, so this is the bell curve, but the more formal word for it is normal distribution, and that's the word we're going to use in this class. So it also has another word that's even more formal, and that's named after the person who invented it, and that's called the Gaussian distribution, named after Gauss. And it looks like bell-shaped. Okay, and in fact, as I said, it comes up everywhere. You've all seen it. If you go to the beach and drop a bunch of sand, you'll see it kind of go in a nice bell-shaped way. I'm not going to explain the physics of why it's a normal distribution when you drop sand on the beach, but it is. And it just comes up in lots of other places. But in our class, the main places the normal distribution comes are going to be when you're looking at surveys. And it turns out it's not the distribution of the survey. It's the distribution of all possible surveys, and that's next week. So right now, I'm not going to get into details on that, but I'm just letting you know that's why we care so much. Is anytime you're doing a survey, the normal distribution is a very important distribution to reference, because when we're calculate probabilities, it'll be from that. So then there is often called the empirical rule. And that is if you look at the mean of the normal distribution is 0 of the standard normal distribution. Any questions on that? You can see it's right in the center, and the normal distribution, you'll also notice, is symmetric about the mean. So the mean and the median turn out to be exactly the same numbers for the normal distribution. So it's symmetric about the mean. And then the standard deviation turns out to be 1 when you have a standard normal distribution. That's basically to make life easy. So that's why we put a 1 and a -1 later on today and for the rest of the quarter. Then we're not going to do a standard and you're going to have different numbers. But for now, I'm just looking at easy stuff. So that means that if you go 1 standard deviation to the left to 1 standard deviation to the right, you look at the area under that curve, which is the probability of being within 1 standard deviation away from the mean when you have a normal distribution. That area is 0.68 or 68% probability. Any questions on that idea? This is called the empirical rule. And note it only works when you have a normal distribution. If you have a skewed left distribution, you don't get 68% if you go 1 standard deviation on either side. That really only works for normal. And just to note, 68%, that's rounded to the nearest whole number. Okay. If you go 2 standard deviations, so that means -2 to 2, and look at the area there, or the probability that something is going to end up being between -2 and 2, that's equal to 0.95 or 95%. That's going to be especially important in 2 weeks when we do something called confidence intervals. And also in 3 weeks, it'll be really important when we do something called hypothesis testing. So very, very important to know these. Then notice if you just go 3 standard deviations, which doesn't seem to be that far, but that's going to cover 99.7% of this graph. So you have almost a close to 100% probability of being within 3 standard deviations of the mean when you have a standard normal distribution. Okay, or it turns out to any normal distribution. This is called the empirical rule. Often it's called the 68, 95, 99.7 rule. Any questions at all on this graph and what these numbers represent? Any questions? As I mentioned, we're going to be using it for the rest of this whole course, so you got to know it. So if you have questions, it's a great time to ask. Any questions? Okay, if there aren't questions, then we'll start using it and playing around. Okay, so let's look at part A. So now I'm going to give you some examples. And basically that we're going to use the empirical rule, which means you use this graph to answer these. Part A is find the probability that Z is between -1 and 1. And the hint is that should be really easy. So maybe you can put in the chat box what you think it is. What's the probability that Z is between -1 and 1? Okay, good. It looks like at least those who popped in your ideas saw that based on the empirical rule, the probability that Z is between -1 and 1 is 68%, or even better, 0.68. So what we can do is the following. The first thing, let me write down Z tilde, Z tilde n 0,1. And let me remind you how to read that. That tells you Z, and Z is going to be the letter we use for the standard normal distribution. That tilde means has a distribution of. N stands for normal. 0 is a mean. 1 is a standard deviation. So if I ask you to say, write down the distribution, this is what I'm asking for. I'm asking for the letter, a tilde, the first letter of your distribution, N for normal, And then when you do normal, it's mean and standard deviation. When you do uniform, it's low and high. So that's the first thing. It's good to kind of write down just to note. Then what I'm going to do say is a probability that -1 is less than z is less than 1 is equal to 0.68. Okay, and just a note, the normal distribution is a continuous distribution. So it doesn't matter whether you put less than or equal to, it's the same thing when you have a continuous distribution for probabilities. Any questions on part A and how we looked at this and came up with the answer? Any questions? Okay, so let's get to part B. Let's see if we can find the probability that z is less than 3. So when we do that, this one's going to be a little bit harder. So here's 3 right here. So 3 is, on the far right. And the probability that z is less than 3 is the area to the left of 3. So there's a few ways of doing it. One way is to say, well, the area to the left of 3 is the same as the area between -3 and 3, but then add in the area to the left of -3. Any questions on that? All right, so let's write that down. Probability that z is less than 3. Strongly recommend whenever you have these kind of questions, the first step is to write down kind of the symbols of what it's asking for, because that's going to help out in planning out how to answer something like this. So the symbols of the probability that z is less than 3 is p parentheses z less than sign 3 and parentheses equal. Okay. Then, as I mentioned, what I'm going to do is I'm going to say I know what it is between -3 and 3, so I'm going to take that. So probability that -3 is less than z is less than 3. But then I need to add in the probability that z is less than -3. Any questions on doing that? Kind of taking that, everything to the left of 3 and putting into these two pieces, -3 to 3, and then that little extra that we have on the tail on the left. All right, so now what's the probability that z is between -3 and 3? And that should be easy. Yeah, although it's better to raise a decimal, so 0.997. 0.997 will be the probability that we're between -3 and 3. So let's write that in first. And then plus, now we need to get the probability that we're less than -3. That one's a little bit harder. So the way to do that is you got to look at these as kind of pieces. All right. Well, we know -3 to 3 has 0.997. So the rest of that, these two tails together, will have 1 minus 0.997. Any questions on that? That's called the rule of complements. But we don't want the two tails. We only want one of the tails. If you know two tails and you want to know one, what do we do with the area for the two tails to get only one tail? It's not supposed to be too hard. Divide by, divide by 2. So what we're going to do is we're going to take the 1 minus 0.997 and divide by 2. And then the rest is boring calculator work. Any questions on this idea? And when you do it in your calculator, 0.9985. I just let you know I did in my head. You should never trust me when I do all the arithmetic in my head, but I think it's right. Yeah, that should be right. So use your calculator and then you'll get it. Any questions on part B? Any questions on how that worked? Okay, let's look at part C. Find the probability that z is between -1 and 2. So p -1 is less than z is less than 2. That's how you write in symbols. Let's make this a little bigger so you can see it here. All right, so we need to find that probability, and it's kind of the same strategy as what we just did. We can say, well, we know between -2 and 2, what's the probability that it's between -2 and 2? The idea is that's supposed to be pretty easy. Yeah, it's 0.95. So what we can write is the probability that -2 is less than z is less than 2. But the problem with the -2 is less than z is less than 2 is that's going to give you all of this area, which means that we've got too much area. This -2 to -1 we put in and we don't want. So we need to get rid of it. So we can go minus the probability that -2 is less than z is less than -1. Any questions on piecing this together? Trying to do pieces of stuff we know and then stuff that we can figure out eventually. All right, so that is equal to, as you mentioned, 0.95, because that's the probability that we're between -2 and 2. And then we got to subtract, and now we got to go to this little piece here. Okay, and the idea is if you take this piece and this piece between -2 and -1 and between 1 and 2 together, well, that would be the same as taking -2 to 2 and subtracting away, cutting out -1 to 1. Okay, and that would be these two pieces, but we don't want the two pieces. We just want one of them. So just like we did in the last one, we got to divide by 2. So we're going to subtract the -2 to 2, which is 0.95, minus -1 to 1, which is 0.68, divide by 2. So I'm going to stop here. Any questions? Are there any pieces that you didn't follow in this arithmetic? How to get to 68? Okay, so 68 right here is between -1 and 1. Do you see that? That's the 0.68. So if I take the 0.95, which has all of this, and I remove this middle part, then I get these two pieces. If I divide by 2, I get the one piece. Does that help, or did I still lose you? Okay, good. Yeah, it's a lot of geometry. It's a lot of geometry. It's like putting pieces together. Okay, no like formal proofs or anything, but just seeing how these pieces like match together, and this one and take away this other one. That's kind of the way this stuff is done. And the rest is pretty boring, hopefully. I think I'm going to show you the quick and easy way. I could do it in my head, but that might take a little bit of time. Instead, I'm just going to copy and paste. And it gives me 0.815. Google's great. It just gives you the answer if you just put it in the in the URL bar. So 0.815. Any questions on part C? Okay. Now comes part D. D is a little different. Let's do this. Yeah, just want to be on its own page. Okay, find the value of z such as a 2.5% probability of being greater than this value. All right, let me make it a little bigger so we can see it better. All right, so we want to say there's got to be a 2.5% probability of being greater than some value. So by the way, if there's a 2.5% chance of being bigger than you, are you big or are you small? What do you think? Yeah, you're big. You're big, right? If 2.5% of the population is taller than you, you're pretty tall. Does that make sense? Okay, so that means that it's going to be somewhere out here somewhere. Do you see that? We don't, know exactly where for now, but what we can say, I think maybe I'll annotate it might be easiest. So I don't know, it might be here somewhere, wherever it is. And then we want to make sure there's a 2.5% probability, which means the area needs to be 0.25. 0.025, sorry. Note that when 2.5% is not 0.25, it's 0.025. Any questions on that so far? Okay. And by the way, I just put it somewhere. Turned out I didn't put it exactly in the right place, but I don't want, to show you that I just know it ahead of time instead of let's just play around. Okay. And the way to do these is to use symmetry. We know that the normal curve, this bell curve looking thing, is symmetric on both sides. So I can actually write down over here that the area on the other side, the other tail, is also 0.25 or 0.025. Any questions on that so far? All right. So how much total area do I have shaded in? Okay, 0.025 is how much is on one side. How much is on the total? Yeah, it's 0.05. Okay. How much isn't shaded in? So if the outsides is 5%, the insides 95%. Check it out. The inside is 95%, which means that in terms of how I did it, I didn't do it exactly right on purpose, by the way. 95% is what's on the inside, and the empirical rule tells us that that's between -2 and 2. So in particular, what's that value right there? And the hint is I didn't draw it perfectly, but I just wanted to give you the idea, and then we can get 95% is in the inside. So what must be the right? What must that value be? What is that value of z? See y'all jump in. Take a look with this 95%. How far to the right does it go? How far does to the right does that value of z go if you're in that 95% area? Yeah, 2. So the answer is 2. Any questions at all on part D? All right, I'm gonna clear it because as soon as I move it, it just messes things up. So I'm gonna clear what I just drew. And I want to look at party. So find the 16th percentile. And here's what I'm going to tell you. I want you to try it. And the hint is it's really similar to what I just did to find 0.25%. Find the 16th percentile. Let's see if you can do that. I'm going to give you about a minute to do that and give it a shot. Okay, and if you have questions, pop in the chat box or ask, and I'll give you a hint. But hopefully you can do this. And the hint is it's in a very similar way. So let's see if we can find the 16th percentile of the standard normal distribution. It shouldn't take more than a minute or two. So let me give you a little bit of time. What is the 16th percentile? Hopefully you're working it out. And when you have it, put in the chat box. And if you can't figure it out, ask a question, and I'll give you some thoughts about it. But it's very similar to what we just did when we found the 2.5% above. Now it's the 16th percentile. Will be a whole number? Yep. Yeah. I'm not going to give you some evil calculation thing. I mean, you may find it evil, but hopefully you don't. It's really not that bad. Yeah, if you don't get a whole number, you made a mistake. Okay, -2, it turns out that would be the 2.5 percentile. One is a good idea. It's kind of you know, looks like you both have some good thoughts and then some things that aren't quite right. If you're in the 16th percentile, are you big or are you small? You're small. And if the average is 0, small means you're over here somewhere. So the answer's got to be negative. Do you see that? Yeah, there we go. Okay, so now let's talk about it. At least we got someone that got it. So the idea here is just like before, 16% is below that number, or 0.16 is below. And then if you go to the other side, on the other side, 0.16 is above. 0.16 plus 0.16 is 0.32. So if 0.32 is on the outside, 1 minus 0.32 happens to be 0.68 or 68%. And then you're on the small side, so that means you're -1. So the 16th percentile is just -1. Any questions on how I came up with that? 16 times 2 is 32. 1 minus 32, 100% minus 32% is 68%. It's on the small side. So in the 68%, the small side is -1. Okay, so let's do one more of these. Let's suppose that z is equal to 1.3. So here's 1.3 on the curve right around here somewhere. Let's see if we can find the z-score. Who remembers the formula for the z-score? What's the formula for the z-score? You can pop in the chat box if you remember. And you can spell out the Greek letters if you because it's too hard to put Greek in the chat box. I don't think it's even possible. And remember z-score? I know it's been a few chapters. That was chapter 2, but it happened. I don't see y'all jumping in. There we go. Yeah, x minus the mean over the standard deviation. So let me put that in, make it fancy looking. Insert equation, and you go z equals, make a fraction, x minus mu. All right, where's mu? Gotta find it. There it is. Over the standard deviation over sigma. I think I'm gonna make that a bunch bigger because it's way too small. That looks better, doesn't it? Equals to a fraction. What's x? In this case. Hint is it's easy. Just have to look. So what I plug in for the x? Yeah, 1.3. Minus, what's the mean for a normal curve? For a standard normal curve. So here's our standard normal curve. What's the mean? Here's our center. It's 0. 1.3 minus 0. What's the standard deviation? Remember I mentioned that? Nice and easy. That's a hint. It's 1. Okay, now my hope is you don't need a calculator to do this in your head. What's 1.3 minus 0 divided by 1? Yeah, it's 1.3. So the z-score for the value of 1.3 is 1.3. So I want to emphasize the fact that we use the letter z to talk about the standard normal distribution, and that's why, because it's its own z-score when you have a standard normal distribution. Any questions on that? Okay, because subtract 0 divided by 1 doesn't change anything. Any questions on this, this set of examples? Okay, now let's do another example. So now what we're going to do is we're going to say, suppose that x follows the normal distribution, but now it's not a standard normal distribution anymore. The mean is 114, and the standard deviation is 23. The way we write that, by the way, is we say x tilde n 114, comma 23. And the parentheses. And that's how you say, or that's the symbols for saying that x has a normal distribution with mean 114 and standard deviation 23. Any questions on that notation? Okay, so again, if you're asked to find the distribution, write down the distribution. That's what this means. It means write it in symbols. Okay, so now we want the probability that X is between 100 and 120. All right, so I will let you know that you have no chance of getting this one if you try to do it the way we just did it, by looking at a picture and kind of coming up with areas and that stuff. And even if you'd have calculus, it's brutal. So I will let you know that this is just brutal to do if all you had was a piece of paper. So what's the good news? Any guess? Yeah, the good news is you use a calculator. And I tried to make it pretty easy to use. So I'm going to go to the calculator. Any guess on what calculator we're going to use? And the hint is that I've made this so it's in the order of which we do things in class. So where are we? Yeah, calculator number 8, the normal probability. Because last week we did the binomial probability. Now we're on the normal probability. It wants the low, the high, the mean, the standard deviation, and the probability. P is probability. And it says fill in all of the values except 1, and then hit calculator. Calculate, and then it'll give you the one that's not filled in. So let's do low and high first. So what's the low and what's the high for part A? Yeah, 100 and 120. Again, I tried to make this easy. So 100, 120. And I want to give you a little heads up. If these numbers, I mean, this isn't, but if the numbers were, say, 100,000, don't put a comma. Don't write 100, comma 000. Just write it without commas. Got it? If you write commas, it'll give you some error. So it's real important you don't put commas in if the numbers are big. Okay. And then we have the mean and standard deviation. What's the mean? And what's the standard deviation? Zero and 1 was for standard normal, but this isn't standard normal. Take a look. The mean is 114. The standard deviation is 23. Any questions on that? So there's a mean and the standard deviation. It also says here, but once you learn how to read it, it's faster to read this. 114 and 23. And then I want my probability, so I leave that one blank and I hit calculate. And there we go. It's about 0.3315. Sound good? Any questions on how I did that? Okay, how about the probability that X is greater than 200? So let's go over here and I'm gonna, if you hit refresh, by the way, it erases everything. So that means I'm starting over. So I want to be greater than 200. So now we go ahead. What's the lower bound for being greater than 200? The hint is it's really easy. Or it should be really obvious. Not 100. Not 90, greater than 200. The hint is it's easy. What's the lower bound? Not 1, 2, there we go, 200. right? If you're under 200, you're not greater than 200. Do you see that? So that 200 is like that stick where, hey, above that, you're good. Below that or below, you're bad. Do you see? So 200. Any questions on that? All right. How high can you go and still be greater than 200? That's a tougher question. Although you had trouble with the 200, which I didn't expect because 200 was 200. So if you want to be greater than 200, how big can you be? $201? Can you be bigger than that? Let's put it this way. I have more than $200 in the bank. What's the most amount of money I could possibly have? Yeah, there's no limit. So infinity. But infinity is not a number. So what you do is you kind of trick the calculator by putting a gigantic number in. And my recommendation is a bunch of nines so that there's 2 more nines than the number of digits of the other stuff. So in this case, the other stuff has 3 digits. Do you see? And that means I'm going to put 5 nines. Okay, if you put 8 nines, it'll give you the same answer, by the way. But no reason to do more than you have to. Any questions on that? Okay, and it can be more than that, but it turns out you'll get the same answer if you do, a bunch more nines. Okay, so 2 more nines than the number of digits of the biggest number you see in the question. And then the mean and standard deviation. We already had that was 114 and 23. And I hit calculate. And what do you see? 0.000092. So I lost count. How many were there? 1, 2, 3, 4 zeros before the 92. Any questions on part B? Okay, let's do part C. What's the probability that X is less than 90? Okay, kind of similar thinking. What's the smallest number less than 90? How low can you go? Yeah. You can go all the way to negative infinity. So you go negative and then 5 nines. What's the upper bound if you can't be bigger than 90? If you got to be less than 90? The hint is that's easy. Yeah, that's 90. Mean and standard deviation are the same. I got to leave the probability blank and hit calculate. And I get out 0.148, call it that. Just a note, I thought there were 2 more nines than the number. Oh, did I not go enough? Let me look. I have 5 nines. Yeah, that's what I've got. So yeah, I got what you wanted. 9999. No, see, 114 has 3 digits. So look at all the other numbers. There's 3 digits in 114. So that's why I made 5 nines. That makes sense? And then you're safe. Yeah, so you always want to look at all the numbers you put in, which one has the most number of digits, and add 2 more. And that will always work. Okay, so that was that one. I think I'm going to skip D because that doesn't come up as much. How about the interquartile range, IQR, which means Q3 minus Q1? Any questions on that question? Okay, what is Q3? Who remembers what that means? Yeah, 75th percentile, or mean the probability is 0.75. So now we have to go back. And the probability now is what we know. Any questions on that? All right, the mean and standard deviation are the same. What don't we know? If we want to find the 75th percentile or the third quartile, what do we not know? Is it the low, the high, the mean, standard deviation, or p? Which is the one I need to leave blank? The hint is it's not going to be p because that's what I just put in. Yeah, we don't know the high. Because it's the number such that the area below that is 0.75, but we don't know that. Area below means we're on the high side and below is on the low side. And then similarly, below that means go all the way to negative 99999. And I hit calculate, and I get about 129 and a half. Okay. By the way, just a note, when you're doing the computer homework work assignments, it'll usually tell you how many decimals to take, and make sure you follow the instructions. If it says, do 4 decimal places, I haven't done enough. If it says 1 decimal place, I did enough. You can get away with doing more than it says, but you can't get away with doing less than it says. Does that make sense? So that's just a note in terms of technical stuff. On the other hand, if you're doing, say, the discussion posts and doing something, then you should do whatever makes the most sense to you. Whatever's going to answer it in a kind of a nice way. So if you're doing, for example, money, you probably want to go maybe 2 decimal places, because then you got dollars and cents. Unless you don't care about pennies, and then you just do dollars. Does that make sense? So that's kind of, how you do this stuff. Okay, so 129.5 minus, and then we're going to do Q1. For Q1, what's the only thing that change? What's the main thing that changes? What do I have to change? It turns out the low is still negative 99999. Don't need another low. What changes? Yeah, it's P that changes. And what's P now? For Q1, what is P? That's 0.25. And we don't know the high because, again, Q1 is the high boundary of that bottom 25%. So I calculate, and you get about 98.5. And 129.5 minus 98.5, I do it in my head, is 31. Hopefully that's right. But you're always allowed to use a calculator. Any questions at all on part E? Okay, let's look at part F. Okay, so part F is the middle 84% of the data is between what 2 values? Okay, that one's going to take a little bit of thinking and work. So I'm going to do what I did before. I'm going to draw a picture because I think it helps to see it. So let's draw a picture. We have a normal distribution. The middle 84%, that means we're something like here to here. And this area is 0.84. Any questions so far in the picture? All right, who could tell me what this area is on the left? The area is always positive. Area can't be negative. But what is that area? 0.84 is in the middle. So how about on the left? Yeah, 0.08, because if there's 84% in the middle, then there's 100% minus 84% on the two sides. 100 minus 84% is 16%. But then if we just want the left, 16% divided by 2 is 8% or 0.08. And so the other side is also 0.08. This is symmetric. Normal curves are always symmetric. All right, so now if I want this value, x, then I can say that 8% or 0.08 is the probability of being less than that value x. And now we're looking a lot like what we had with the IQR, the quartiles. So 0.08 is going to be our probability. We want to go from a bunch of 9s to we don't know the high. That's the whole point. Any questions on that? And we calculate. And what we get is about 81.7. So 81.7. And then if we want to get this guy over here, well, we know there's 8% now to the right. So now I can go ahead and I'm going to have a probability of 8%, but now it's to the right and I don't know the low, but the high will be 99999. Anyone lost on that? And if I calculate, I get 146.3. So there's the two values. So the probability of being between 81.7 and 146.3 will be 84%. So I'm going to stop for a second. Any questions at all on this work? Okay, so let's look at the last one. Find the z-score if the x value is 117. So for this one, all I do is I pop in the z-score formula. Z equals fraction. And it's going to be x. X is 117 minus mu. Mu was 114 divided by sigma. Sigma was 23. Probably way too small to see, so let's make it bigger. Any questions on that? So that is, let's see, 3 over 23.1304. Yep, that sounds right when I do it in my head. Any questions on that? Any questions? Okay, it doesn't look too bad, does it? What do you think? Most people don't complain about this chapter, which means you should spend, a lot of time this week working on your project, because you kind of have an easy week when it comes to, the new stuff. So definitely project time. Any questions on this example? Let me erase these guys now so it doesn't mess it up. Okay, so now we're going to do a little application. First application, so let's give some space. All right, so it was a fun one. Okay, suppose that the time until you or your wife, if you're male, will give birth is normally distributed with mean 140 days and standard deviation 7 days. Okay. By the way, a couple things. Do we have anyone in healthcare in this group? Pop in the chat box if you want to go into healthcare or you are in healthcare. Could be a nurse, could be, okay, so we got a few. Okay, I think I mentioned it. This is what my brother does for a living. He delivers babies. That's his job, which is nice because most of his patients are happy, which is so much better than most other medical professions where most of the patients are like in misery. So that's what he does. And what if the mean is 140 days? What does that mean? Just kind of in like nice, easy words when you talk to people. No one's going to say, my mean of delivering a baby is 140 days. What are they going to say? Average, probably not average, actually. You're going to ask them, for example. What question do you ask them? I don't hear. When are you expecting? That's the English way of saying it, right? And if they say, I'm expecting in 140 days, that's the mean. I don't know if you've thought about it, but that's what that is. That's what that means. Because it's an expected value. So now I'm throwing in statistics in things that you've heard about, in things that you never thought of statistics. But when they say, hey, I'm expecting in about 140 days, that's the expected value. So if you're wondering that's what that means. So the expected value is 140 and the standard deviation is 7. Just a note, it used to be a normal distribution. Okay, it used to be that when you're going to have a child is normally distributed. I don't know why it's not anymore. This is not a math question. This is a health question. So the person who said they're in health, then you might have a better chance, but nothing too fancy, but a little bit. You don't know why it's not normally distributed anymore when it used to be? Or possibly normally distributed? Not seeing, I'll jump in. Should I tell you? C-sections. That changed everything. So if you only have a natural birth and you never have a C-section, then it actually is almost perfectly normally distributed. But then C-sections kind of change the distribution because then all of a sudden, if it's been too long, they just pull it out. That's the way it works. Okay, so we're looking at we're going to be expecting in 140 days. Standard deviation is 7 days. All right, so here's the bad news. Your boss has just scheduled you or your wife for a business trip to China. Is that a good idea, by the way? Okay, well, if you're coming back in a day or two, it's no big deal, right? 140 days is like forever. Okay. But here's the problem. You or your wife will leave today and will return in 135 days. Does that sound like a good idea? And by the way, one of the things you really want is you want your baby to be president of the United States someday. Means they should be born in America, or people are going to say, hey, they're not even a citizen. They weren't born in America, which is you have to be, and all that kind of stuff. All right, well, we don't know yet, but let's find out. Let's find the probability that your baby will be born in China. Any questions on the question? All right, so what I'm going to do first, before I even read A, I'm going to write X. And then I'm going to write tilde. N, because we're told it's a normal distribution, 140, 7. Any questions on taking this first sentence and turning it in to our normal distribution notation? It makes it a lot easier to read the numbers out. Okay, for part A, we want the probability that what should I put inside the probability equation? If we want to make sure, if we want to find out what's the probability the baby will be born in China. If you think about it, it's not that hard. But you have to know how to read these things and come up with these probabilities. For example, if the baby's born in 120 days, is it born in China? Yeah. How about if the baby's born in 140 days, is it born in China? No. So what inequality is it for it to be born in China? What makes it born in China? We saw 120 days is born in China, 140 is not. You're going to return in 135 was what you looked at. So what do I put in? Probability that X, not 135 to 140, X dash 135 or minus, not minus, X is less than 135. Because if the baby is born before day 135, it's born in China. If it's born after day 135, it's born in here. Does that make sense? Any questions on that? Okay, so once we have that, then we can go to the calculator. Less than 135. Let's do that. What's the low for less than 135? It turns out there's two good answers and they both will give you the same thing at the end. Yeah, negative 99999. If you want to make it more realistic, then you can go 0 if you want, because the baby couldn't have been born last week if the person's still pregnant. But it turns out whether you use 0 or negative 99999, you'll get the same answer. Okay. When you have a standard deviation of 7 days, that's way too many standard deviations to be having a chance of now. Okay. And what's the high? Yeah, 135. And then let's go back. The mean was 140. The standard deviation is 7. And I just hit calculate. And let's go 2 decimals, 0.24. Okay, 24% chance of it being born in China. What do you think? Are you happy about that? Would you be okay with that? Any thoughts? Right. And we're given the fact you're not like from China or anything like that with family or whatever, that that's not where your background is. Would you be okay with that? Would you be okay with a 24% chance? This is supposed to be an easy answer. Yeah, hopefully no. No, you don't want to be in some other country when you're having your baby. And 24% chance is pretty darn likely. Okay. It doesn't mean it's going to happen, but it's enough to get you really worried. If it was like 0.24%, or 0.002, then that might be fine. But 0.24 is a pretty big chance. So let's go to B. You decide it's too risky. And you want to negotiate with the boss. Okay, that's how business works. And you want to ensure that there's no more than a 1% chance that baby will be born in China. What day should you be asked to return? Any questions on that, on what the question is asking for? All right, so now what we're going to say is the probability that X is less than our return date needs to be just 1%. Any questions on that? Because now we don't know the value of X and we want to, but we do know the probability. So now we can go ahead, pop in the probability is 1% or 0.01. We don't know the return date, so that's blank. So stop me if there's any questions on what I just did. Same mean, same standard deviation, same low. Just for fun, I'll put 0, but it really doesn't matter in this case because that's a cut. That's it turns out that if the standard deviation is 7, the mean's 140, that would be 20 standard deviations away, and that never happens. Remember, 3 standard deviations is really rare. 20 is like never in like the universe rare. Hey, calculate. So when should you return? After how many days? Yeah, 123. Okay, this is one that you probably don't want to round because 124 is going to be slightly higher than 1%. And you want to be slightly lower because that's what the question said. So return in 123 days. Any questions on this example? All right, now part C is a little different. It's now 130 days later. Okay. You hear a lot of pregnant people talking about this, by the way. And now the baby still has not been born. Okay. When's the due date, by the way? Do you remember? Yeah, 140. Find the probability the baby will be born within the next 24 hours. Okay. So this is a given question because we're given information. We know the baby hasn't been born yet. This is going to be the probability that the next 24 hours, that's from day 138 to day 139. So probably that 138 is less than 139. Sorry, less than X is less than 139, given that X is greater than 138 because it hasn't been born yet. That means you know it didn't happen, say, in day 135. Any questions on this example so far? Okay, so now I go equal. Now you got to remember chapter 3. When you have a given problem, the probability of A given B is the probability of A and B divided by the probability of B. So I'm going to write the probability. Okay. By the way, if you're between 138 and 139 and you're greater than 138, that's the same thing as just being between 138 and 139. The and 138 doesn't give you anything new. So that's the probability that 138 is less than X is less than 139 divided by the probability that X is less than 138. Any questions on that? And now the rest is calculator work, 138 to 139. Now we just do that. We don't know P. Low is 138. High is 138. High is 139. And I hit calculate. 0.0557. How about? And then divided by the probability that we're less than 138. So if you're less than 138, that means the low is negative bunch of 9s. And the high is 138. And it calculate. Whoops, forgot to leave the probability blank. And I hit calculate, and I get 0.3875. And now I can just take that, go to the scientific calculator, divide those numbers, too many divisions. There we go. I think I forgot the point. There we go. That's better. And it looks like about a 14% chance. Did I lose anyone there? Okay, by the way, if there's a 14% chance you're going to be giving birth in the next 24 hours, you better stay near your hospital. Don't go too far away. One of those things. Because it's probably a bad idea to be out in the middle of nowhere. Any questions on part C? Not too bad. Okay. There's one more example I want to do. Application example. Okay, suppose that the amount of ice cream that you sell, so let's say that you have an ice cream store, and the amount of ice cream that you sell each day is normally distributed with mean 950 ounces and standard deviation 120 ounces. Is that clear? Okay. And these are the kind of things that you do using data. You do some research and you see that it works. That's how you come up with that in business, is you look at your data. Find the probability that a randomly selected day, you're going to sell between 900 and 1,000 ounces of ice cream. So the first thing I always like to write X tilde N 950 comma 120. Just makes it easier to just use that for the rest of the whole problem. And for part A, we want the probability that 900 is less than X is less than 1,000. Any questions so far? Now we just put them in. I'm going to refresh. What's the low and what's the high? It's not a trick question. You should be able to put it in the chat box pretty quickly. Yeah, low is 900 and the high is 1,000. So let's do it. Low is 900. The high is 1,000. And then the mean, 950, standard deviation 120. That was 950 and 120. And I just hit calculate, and there you go. 32% chance, 0.32. Any questions on that? All right, let's look at part B. In the morning, you took stock of your supplies and noticed you have 1,100 ounces of ice cream in your store. Okay. Okay, which is more than the average, right? So you'll probably be okay for the day, right? But maybe not. What's the probability you're going to run out by the end of the day? So one of the things that I want to, give you a heads up, but at this point you probably understand because this is week 4 already. Probably the hardest part of the statistics class is reading the sentence and coming up with what you're supposed to do. I don't know, do some of you agree with that, or that's not hard for you? Yeah, that's usually the hard part. And the best way of getting good at it is practice. Because you can watch me do it. That's not the same thing as you doing it yourself with practice. So try to stay ahead of me and see if you can get it before I do it. One reason I'm just kind of talking, because now I'll do it. So you want the probability that you're going to run out. If you run out of ice cream, what does that mean the demand is? What will the demand be if that means you ran out? If you only had a couple people that went into your shop to get some ice cream, they only want 20 ounces, are you going to run out? No. How about if you had more people and they wanted 200 ounces? Are you going to run out? Still not. Okay. Right. So when are you going to run out? And that's what we want the probability of. How much demand will there be if you run out? Remember, you have 1,100 ounces. How much demand must there be for you to run out of ice cream? Yeah, demand of more than 100, than 1,100. Yeah, greater than 100, 1,100. Any questions on that? So we want the probability that X is greater than 1,100. It's usually the hardest part about these problems is to read the sentence and see if you can come up with, how you write this out. Once you write it out, then it's pretty easy. Any questions on how I came up with X greater than 1,100? If the demand was 2,000, you ran out. Do you see? And then the rest is easy. Greater than 1,100. So what's the low for greater than 1,100? Not negative 999, not zero. Zero is not greater than 1,100. 1,100 is a low. Anything bigger than that, you run out. So that's the smallest amount. That's the boundary of the run out spot. Do you see? What's the high? Yeah, now it's a bunch of nines. Notice there's 4 digits here. So I do 4 nines and then 2 more nines. That'll always work. Okay. And then the probability is what I want. So I leave that one blank and hit calculate. Looks like about maybe 11% chance, 0.11 all round. Any questions on part B? I do want to give you a heads up. It's a lot easier to watch me do it than you do it. So make sure you practice a bunch of these. Okay, and the homework is a good way of, the chapter assignments is a good way to practice. Okay, now you want to be 99% certain that you're not going to run out of ice cream, because as a manager, that's what you want. Because if you run out, then what's going to happen is all of a sudden people are going to be pissed off as they walk into your ice cream store and say, oh, I'm sorry, we don't have any ice cream. They're never going to come back again, and they're going to tell all their friends never to come back. So you want to be pretty darn certain you're not going to run out. Does that make sense? So how much do we need to have in stock at the beginning of the day? Any questions on the question? So now we're going to say probability that X is greater than something we don't know needs to be equal to 99% or 0.99. Sorry, 0.99, but then it's going to be less than what we don't know. Because if you don't run out, that means you had less demand than the amount you stocked. Does that make sense? So now we go back to the calculator. 0.99 was our probability. How about low and high? Which one's blank? Yeah, the high is the blank one. What's the low? Yeah, you can go 0. You can go 0. You could also do negative 9999. You get the same answer. I try not to keep trick questions that way. And I hit calculate. And I get about 1,229 ounces of ice cream. And then you'll be 99% sure that you're going to be not running out, which is what you want. You want to be very rare chance of running out if that's your business. Any questions on this idea? So these are some applications. I'm going to let you know next week is when we do the more realistic applications. These are fun and these can happen, but the next week we're going to know that they're going to happen. So just one of these, just be patient is all I can say. And you'll see why we really need the normal distribution. All right. So that's pretty much what I needed to say, except for the secret word. And I decided to have the secret word this week to be bell, because if you have a normal distribution, the shape is a bell curve. It's kind of bell shaped. So that's why I decided a good secret word would be bell. I try to make the secret word that you may not immediately guess, but something that relates to what we're doing. So bell. And so that's pretty much it. I want to let you know again, we're a little below the time we usually quit, which is fine. I told you today was a little bit easier than usual. Next week is a little more even. We're going to be using the normal distribution in a very deep way with something called sampling distributions. And that'll be a big one. So next week is one of the more confusing weeks. So definitely, plan on being a little confused. This week is usually not a confusing week. Not too bad. So just a heads up. And I think I'm going to stop the recording.